Topic: Construction processes. Soft soldering. Application and methods. Equipment. Types of solder. Fluxes. Safety. Introduction. The content covered in Grade 8 and 9 Agricultural Studies and Grade 10 Safety links in with the content that will now be covered. Grade 8 Safety. Grade 9 Safety. Grade 10 Safety. The purpose of this lesson is to provide content associated with soldering to treat. Concepts and skills. Soft soldering. Soldering is a process in which two or more metal items are connected by fusing in the flow of a filler metal. Solder: in the weld, the filler metal has a lower melting point than the workpiece. Soldering differs from welding in that in soldering the weld is not melted. There are three types of soldering, each requiring a higher temperature and each providing an increasingly stronger load strength. Soft soldering: use a tin lead alloy as the filler metal. Silver soldering: use an alloy with silver in it. Brazing: use a copper alloy for filling. The alloy of the filler metal for each type of solder can be adjusted to change the melting temperature of the filler material. Soldering seems to be a hot gluing process, but it differs significantly with gluing processes. Because the filler material alloys with the workpiece at the joint to form a gas and liquid tight connection. Soft solder's filler metal is characterized by a melting point below 220 degrees Celsius, while silver soldering and welding. Soldering require higher temperatures which are weighed by a flame or carbon arc welding apparatus to effect the melting of the filler material. Soft solder filler metals are typical alloys, often with lead, with melting temperatures below 250 degrees Celsius. Origin. Soldering and brazing presumably originated very early in the history of metalworking, probably before 4000 BC. Sumerian swords of 3000 BC were manufactured using hard soldering. Small statue is created by soldering. Soldering has historically been used to make jewelry, cookware and utensils, as well as other uses such as in assembling colored glass. Application. Currently, the two most common uses of soldering are in plumbing and in electronics, where they are used to connect electrical wiring and electronic components in printed circuit boards. It provides fairly permanent but reversible connections between copper pipes in plumbing systems as well as the loads in sheet metal objects, such as cans, rain gutters and car coolers, jewelry components, machine tools and some refrigeration and plumbing components are often repaired using higher temperature silver soldering processes. Each form of solder offers advantages and disadvantages. Soft soldering uses the lowest temperatures, but it is not a strong load and should not be used for load-bearing loads. It also cannot withstand temperatures and is thus limited to normal ambient temperatures or below. Silver soldering, as used by jewelers, requires the use of a flame or other high-temperature source and is much stronger than soft soldering. Brazing provides the strongest connection but also requires warmer temperatures to melt the filler material. Some examples of soft solder types and their applications include tin lead, general purpose, tin zinc for the welding of aluminium, lead silver for strength at higher than room temperature, cadmium silver for strength at high temperatures, zinc aluminium for aluminium and corrosion resistance, and tin silver for electronics. Step-by-step instructions. Secure positioning of soldering iron. When using a soldering iron, be careful not to burn yourself or any part of the vehicle you are working on. The tip of the soldering iron is hot enough to melt metal solder, so make sure it is in a safe place and does not touch anything. Prepare the wires to be connected. Remove an appropriate amount of the protective insulation around the wires while the soldering iron is heating up. Always use a proper stripping tool that is in good condition. Load the wires mechanically. Twist the wires together to make a good mechanical connection between them. If there are impurities in the solder, and the wires do not touch directly to each other, there may not be a good electrical connection. Although there may be a strong physical connection. This is known as a dry connection. It is also very important that the surfaces are very clean before soldering is done, otherwise there will be a weak connection. Place solder on wires. Use the soldering iron to gently heat the wires and melt some solder. Place the soldering iron on the wires to ensure that only enough solder runs in the wires. Be careful not to use too much solder, and if you apply too much heat you will melt the wire insulation. When you have finished soldering, clean any excess flux with a cloth and a little solvent from the weld. Place a casing over the load. Once the electrical connection is made, and it has cooled enough for you to handle it, you can cover the load with an insulator. It can also be electrical insulation tape, isolation tape. Turn on the solder. Give the wires a thin preparative layer of solder. This is called tinning of the wires and helps to make the final connection. Prepare the surfaces with flux if not absorbed into the core of the solder. Place the wire back in the terminal, and place the soldering iron on the terminal to get it hot enough to melt more solder between the terminal and the tinned wire. Be careful not to use too much solder, and if you heat the terminal too much, the wire insulation will start to melt. Cover the terminal. Once the electrical connection has been made, and it has cooled down enough for you to handle, you can place the insulator cover over the terminal and test the connection. Equipment. Hand soldering tools includes the electric soldering iron, with a variety of points available ranging from blunt to very fine points, and the soldering gun, which offers more power and which builds up heat faster so that larger parts can be soldered. Hot air guns and pencils allow rework of component. Solder flame is a type of soldering device that uses a flame, rather than a soldering iron tip to heat the solder. Solder flames are often powered by butane and are available in sizes ranging from very small butane/oxygen units that are suitable for very accurate but high-temperature jewelry work, and the full-size oxyfuel device that is suitable for many larger works such as copper pipes. A copper soldering iron is a tool with a large copper head and a long handle that is heated in a smoldering fire and used to provide heat on sheet metal for soldering. Wire brush, wire wool and emerald cloth are commonly used to prepare plumbing welds for the weld. Electronic joints rarely require mechanical cleaning. Alcohol and acetone, one or the other, is commonly used with cotton swabs or brushes to remove flux excess. A heat sink, such as a crocodile clamp, can be used to protect harmful heat-sensitive components while soldering. The crocodile clamp absorbs the excess heat and thus protects the sensitive components. Types of solder. Solder filler material is available in many different alloys for different applications. Electronic circuits requires eutectic alloys of 63% tin and 37% lead. 60/40ths. Other alloys are used for plumbing, mechanical connections, and other applications. Ordinary solder alloys are mixtures of tin and lead, respectively. (63/37ths) melts at 183 degrees Celsius. 60/40ths melts between 183 to 190 degrees Celsius. 50/50 melts between 185 to 215 degrees Celsius. For environmental reasons, and the introduction of regulations such as the European restriction of hazardous substances, lead-free solder is increasingly being used. It is recommended where young children come in contact with it, because young children tend to put things in their mouths. Soft solder fluxes. The purpose of the flux is to facilitate the soldering process. An obstacle to a successful solder joint is an impurity on the environment of the joint, e.g. dust, oil or oxidation. The impurities can be removed by mechanical cleaning or by chemical means, but the elevated temperatures that melt the filler metal, the solder, cause the workpiece and the solder to oxidize again. This effect is accelerated when the soldering temperatures are high and can prevent the solder from combining with the workpiece. One of the earliest forms of flux was charcoal, which acts as a reducing agent and helps prevent oxidation during the soldering process. Some drugs go beyond the simple prevention of oxidation and also serve as a form of chemical cleaning, rust. For many years, the most common type of flux used in electronics, soft solder, was glue-based, using the glue from selected pine trees. It was non-corrosive and non-conductive at normal temperatures. Plumbing and car applications, among others, usually use an acid base, hydrochloric acid, flux that requires cleaning of the load. This load cannot be used in electronics because they are conductive and because they corrode the small diameter wires over time. Soft solder fluxes are currently available in 3 basic formulations. Water-soluble streams, no requirement for removal, a high-activity flux designed to be removed with water. After soldering, no cleaning fluids that are fluffy enough and not needed to be removed due to the non-conductive and non-corrosive residue. Traditional adhesive fluxes are available in a non-activated, slightly activated and activated formulation. The fluxes contain glue combined with an activating agent, typically an acid, which increases the erosion of metals. Safety. Personal safety. When performing a task in the workshop, you must use personal protective clothing and equipment that is appropriate for the task and that complies with your safety regulations. These may include the following items: work clothes, such as overalls and steel-coated shoes. Eye protection, such as safety glasses and face masks. Overprotection, such as earwax and earwax. Hand protection, such as rubber gloves and barrier cream. Respiratory equipment, such as face masks and valve respirators. Safety notes. The soldering iron tip should be very hot to allow solder to melt. Do not burn yourself with the soldering point. Do not inhale the fumes released during the soldering process, they can irritate your respiratory system. Do not use the electric soldering iron when standing in water. Never solder on a live electrical circuit. Make sure you understand and maintain all legislative and personal safety procedures. Points to note. Solder used in car electrical connections is an alloy typically consisting of 60% tin and 40% lead. Solder should easily change from a solid state to a liquid state and vice versa. Solder is available as solid or liquid core solder. Solid solder requires an external flux in the soldering process. Liquid core solder has a flux in its core. Fluid is needed to prevent the metals from oxidizing when heated. Fluid is usually acidic and must be removed after the soldering process so that the load does not wear out. Soldering is done with a hot soldering iron. The soldering iron heats up electrically or through an external source such as a butane or oxyacetylene flame. The soldering iron tip absorbs heat which is then applied to the material to be welded. Once they are hot enough, the solder is able to melt between the components. For a load to be successful, the soldering iron must be tinned. The tinning process helps in the transfer of heat to the wire. The soldering iron tip must be heated, and a small amount of the solder is placed on the tip. Excess solder is removed with a cloth. The soldering iron tip is placed on the wire so that the heat is transferred to the wire. Do not apply too much heat, otherwise the insulation may melt. Activity/assessment. Teacher must work out activities on the given content and provide them to the learners. Consolidation. The lesson covered all the content as required by the CAPS. The learners understand all the concepts and content.
Please like, share, and subscribe to the channel for more future educational videos.